So in short about me first, my name is Ashish Nanatkar, and I'm here in IT industry field for last 7.5 years now. And I've been in DevOps for last almost 3 years, helping bigger organizations to help to get their DevOps set up. So I also work as a DevOps coach and agile coach, helping people to transition from non-DevOps architecture to DevOps architecture. So let's talk what is DevOps. That's a small agenda about today. We'll be covering up what is different between the containers and virtual machines. So what are the virtual machines we are using these days and why they are not the best suited practice for a few of the environment scenarios. So I don't say virtual machines are bad. It's just that they wouldn't fit in some of the scenarios that we'll be discussing for the production environment. DevOps would be a help. The Docker would be a help in DevOps for those specific scenarios. We will be learning a few things about Docker, how to deal with it, how to install it, how to get through the basis of Docker so that you quickly get to a level where you could investigate more and discover more from the Docker ecosystem. Okay, so that's what is the agenda for today. Let's start off. Right, this is a usual problem that anyone would face. Generally, what happens? Developers would develop something, then the tester would try to test it on his box. So while the developer is away, the code is just pushed there. It may not work. There's no guarantee of that. The reason why this happens, the settings on your developer machines are most of the times different. Okay, because there might be debugging enabled, some info level logs are enabled. Some rewrite rules may not be available there. Okay, the configurations on the web servers might be different. You have not built the code correctly, or few of the dependencies on the stage servers or the pre-production servers are missing. There could be n number of things that could probably go wrong, and this is just because DevOps isn't done right. Okay, so DevOps tries to bridge the gap between agile development and non-agile operations work, where we attempt to make the operations side of it to be agile, okay, to be more flexible, to be automated. And Docker would be one of the link between that to replicate the environments. So how do we make it possible? If that's one of the problem, right? Another problem is that the development and production environments are not the same. In the production, the system configurations might be different. The server configurations or versions are different. Generally, what happens is whenever we develop it, we develop the code keeping in mind the future. So let's say currently my application is running on PHP 5.4, but we are experimenting in the organization on PHP 5.5 or 5.6. Might happen. Or even in the case of Java, if my application is running on JBoss 7, 6 or 7, and I want to try Wildfly or something like that, I will be developing the code according to that. So it works on my machine because I'm working on it, reiterating over stuff, trying to perfect it. That works. When the code leaves my box, there's no guarantee that it's bound to work. Right? On the production, the things are going to be different. There are very different scenarios as well. Let's say for deployments, these ops people wouldn't understand the code, and we wouldn't understand the ops side for sure, being a new developer. So what I do is I will be creating some steps that you need to follow these steps in order to build the code and then deploy it. Okay, that's how I do that. I do these things being a typical developer. Okay, so if I do that and I forward the scripts onto the ops side, the ops people, they don't understand the coding part of it, so they would be following those steps, trying to build the code, and wouldn't work for some other reason. The reasons could be that they missed a few steps, or I forgot to include one of the steps that I thought was very trivial or a part of common sense logic. So due to these kind of human errors, the stuff goes wrong. Okay, so what we need to bring in? We need to bring in automation. We need to bring in computers. We don't want to trust humans in creating the installation scripts and then running them manually onto the production systems. More often, this is all about environments. If I guarantee that environments on both the sides are supposed to be same, somehow if I make them same, in that case, if I move the code or my build artifacts from one location to another machine, it should work. Okay, ideally that should work, at least in theory. And this problem is solved by Docker. So what Docker would do for us, it would replicate the platforms. Okay, you know Java, right? So if I have a Java code, why is it called to be portable? It's not because the code could be executed on my machine, or there are Java interpreters which are installed on different machines for different platforms. It's not that. It's because the bytecode that is generated from that sample code which I have could be executed on any of the boxes. It doesn't mean that the underlying architecture of that Java compiler or Java interpreter is same. It means that the code that I am building, it is understood by any of the underlying architectures. Okay, the same thing is with Docker. What Docker does is Docker uses the underlying platform called kernel. Eventually, it works on the concept of Linux containers. We will talk of the container part soon. So, what is Docker in a nutshell? It's an open source application. Okay, Docker is rather a company which brought the usage of Linux containers to the public. That's why we call it as Docker. Okay, their product name is also Docker, and it's open source platform that packages your application dependencies and the configurations together. And how does it do it? It uses a different kind of file system in which layers are placed on top of the kernel. So imagine you have virtual machines running your code, and all of the virtual machines that you use would have their own resources which would be emulated for them. They have their limitations in form of resources. If you are aware of VMware or VirtualBox or Virtual PC, Word Manager, any of the hosted hypervisors or even bare metal hypervisors for virtual machines, what we do is we tell the hypervisor that this particular virtual machine should be granted so and so amount of CPU, a few gigabits of RAM, so much and so much hard disk, and it would work according to that. Okay, Docker, in other words, wouldn't be bounded to those kind of resource utilizations. What it does is it works just like a structure of Java. It is very analogous to that, but I wouldn't say exactly same like that because the underlying concept is very different. So they have Docker engine. On top of that Docker engine, you would be running your Docker code. Okay, so you could port your Docker machines anywhere. But right now, let's keep the Docker term as very vague. We don't understand what Docker is. We'll come to that when we compare it with virtual machines. Okay, so Docker is not a virtual machine. If it could do all the things like a virtual container, does it act as a virtual machine? No, it doesn't. What is the difference? The difference is, very first, there is no separation of resources between two different Docker containers. Okay, so physically you cannot separate it out. You cannot say that this Docker container of mine would be granted a 1 GB image resource and another one would be having another 1 GB of it. They both can share the same RAM, practically basically the same locations. In theory it could do that. Okay, but generally what we do is we have kernels handle all those things for us, just like different processes on a CPU or on a machine. All the 100 processes on your operating system would be running fine, even if they are running on one single box, one single CPU, sharing all the resources and memory, unless and until they explicitly step foot on someone else's memory, right? Everything would be fine. But if you do that, you would run into a conflict. Okay, that's what is the problem with Docker. Now that's the biggest issue. Um, if you run the Docker containers using super user and the super user wants to do something at the root level, he would doing it. Okay, that's possible. But with virtual machines, you cannot play with the resources of some another virtual machine. They are completely isolated. So isolation here from the security point of view in Docker is a problem. Okay. Another benefit with Docker is that Docker is very light. Your virtual machines are not light. When you install a virtual machine, you first give them a hold of the resources, which would be emulated by the hypervisors beneath. And on those resources, the virtual machine would be playing. It would have its own memory management. It would have its own process management. It would have its own background processes running. Okay, and a whole lot of stuff which is going on for a typical operating system would be there. Sort of 1 GB of RAM almost 600 MBs or something like that, whatever your operating system is, depending on that, it would be using the RAM. So very less amount is left for actual servers or daemons to run on top of it. Okay, but with Docker, you get complete amount of that. So if your host operating system is running maybe 16 gigs of RAM, your Docker instances would be having hold of all the 16 GB. Whether it uses or it doesn't use that, it's all up to itself. Okay, so it's different than a virtual machine though. Since virtual machine have got isolations, strict isolations, there is no problem of security, which would be a problem in Docker. Docker are very light. Docker containers are very light. They don't have any of the internal mechanisms like an operating system. Everything that is required for the process to run, including the dependencies, including the files, all of those stuff is handled by the kernel itself. Okay, so when we are talking of kernel in virtual machines, every virtual machine would be having their own kernel, but in case of Docker, the host system provides the kernel for the Docker processes to run. So Docker only takes care of process isolation. Process level isolation is very good with Docker. So processes wouldn't be stepping on each other's feet. The isolation at that level is very good, but when you talk of the underlying CPU level, at the crude resource level stuff, it's really flaky. So that's what the problem is. And that's the only reason people are fearing to execute Docker in the production these days. But it has got big scope. People are looking towards it. It's very promising software. Okay, but how do we make use of it? So since Docker works on the concept of layering, so you could actually run many multiple processes on the same kernel, right? They can be separated out, and every process would be supported by the same kernel, so the resources doesn't have to be managed by the processes. These resources are managed by the kernel itself. So if one of the process or one of the Docker containers is requiring more amount of RAM, it takes it. Okay, it would be granted to that. Here, at the another difference between Docker and virtual machines is in virtual machines you have a complete operating system running, but with Docker you're actually running only one single process. It could be one, it could be two, any number of processes, but ideally we keep this services separated out using Docker. There are people who have tried installing operating systems inside of Docker as well. That works. Okay, it's not a problem. Docker can run your complete operating system as well, but probably not a good idea. Okay, because we use Docker for keeping the systems light. We don't want to burdenize it. Even if in case of hypervisor, if you check both of these figures, in your virtual machines, you would be having a hypervisor running which has its own kernel, and on top of that kernel, each of the guest operating systems will be having their own individual kernels. The total kernel count is 4 in this case. That is 4x times the resource requirement just for executing a kernel. I'm not talking of any of the daemons here. If you talk of the Docker engine, there is no hypervisor requirement. Docker engine would take care of forwarding all your instructions and requests from within your Docker containers to your underlying host operating system. That operating system has its own kernel. So there's kernel count is 1. We don't have any process management requirements, no memory management stuff to be done on individual Docker container level, and apps can run in isolation from one another. Like in case of virtual machines, and we have network managers, we have the same thing here in Docker as well. So Docker containers get their own IP addresses. They can talk to another Docker containers. We could link them together. But why do we use Docker in first place? Resource utilization, optimization, and performance. Okay. There's a question coming in from Manish, Mr. Manish. How is Docker able to get hold of entire memory of operating system? Well, that's a good question. The question is not how. The question is why it doesn't limit itself to something. Now, these kind of limitations are offered because of the kernels. Okay, So if you're talking of an hypervisor has its own kernel which can separate out the things for the different virtual machines which are running on top of it. So there is a separation which is considered by hypervisor. But here in case of an operating system, you know that the operating system can be using 100% of your system resources. Any operating system you install on any of the hardware, by default, it utilizes all their system resources. So imagine there was no Docker engine on top of it. So how much RAM you consider this operating system would be using? All of it? So there is just one kernel which is utilizing whole of the RAM, and there is no separation between the different virtual machines. There are no virtual machines rather. So Docker engine, when we install that Docker engine package on top of your operating system, it actually picks up the complete amount of RAM which is available, okay, which would be free. So in that particular RAM, it could host as many processes as it wants. Ideally, we keep one process per container. Okay, so those many containers can be executing. So if my process on Windows, let's say I open up a task manager, all are familiar with task managers. So if I open up a task manager on my system and I say that I have 12 gigs of memory and there are processes which are using that memory, okay, so there is a complete possibility that one of the process would be taking up complete RAM, but it does not. Okay, so currently my browser would be taking in 122 MB of RAM, but it could potentially take up complete 12 GB. Same is with the Docker containers. It runs as a single process, just like any other process. Okay, so it would take its own requirements as per its own requirement, but it wouldn't go beyond what is considered to be harmful. If it does that, that means something is definitely wrong with that container. Okay, so it's up to us how do we design that processes which are executing inside the Docker container. Now, Docker has been designed in such a way that it could be incorporated with many other DevOps tools, including the very famous ones. So all the configuration management systems can connect with Docker. They could change the configurations. They could build the Docker images. Okay. One another fantastic use of Docker is to have version control system. Well, I'm not talking of the regular version control systems. I'm just talking in a term where you are saving some snapshots in time. Okay, so we could have operating system running or a process running, and I could commit that snapshot somewhere so that I could go back to it and I could maybe rerun it or even evaluate it for some reason. It's just like storing snapshots for the VMs. But these snapshots that Docker creates are layers. Okay, so they are very light and they do not take much of the space. And actually, you could also do a Docker diff command on it, and it would actually tell you that how many files were changed between the last revision and the current revision of the Docker commit snapshot. So the Docker containers, like I told, would be able to integrate with one another. The containers can talk to one another. They can have IP addresses, so they could connect to one another if they want to. You could also create a complete ecosystem in Docker. So there could be a Docker container having Postgres, another one would be running something else, maybe some web server, and you could have that web server talk to the Postgres um, Docker container all within your system, and that also without knowing the IP address of it. They would be linked together to form one unified Docker container as a whole. So you could see two, but internally they would be treated as one. Okay, that could also be done. So I'll show you different examples during the Docker hands-on session. Let me take up a few queries before starting off. There is a query from Sandy. If I restart the operating system on with respect to Docker engine, all the processes running on it will also stop, which is not good. Yeah, if you restart the operating system, the host operating system, your Docker is gone. It's all based on the kernel which is provided by the base operating system, and you are right in that. Same is with the hypervisors. If the hypervisors would fail, none of your virtual machines would run, right? Same thing happens here. So in the Docker architecture, there is another question from Manish. So in the Docker architecture, is it not becoming a single point of failure? because if Docker layer becomes unresponsive, things hang. Yeah. So it's true with any other software. It could be true with the hypervisors in case of VMware as well. Okay. So if your hypervisor fails or stalls, your machines are lost, all of them. And same is the case with Docker or any piece of software which acts as an intermediate layer. So we all trust OSI layer model, right? All the 7 layers through which all the integration, all the network traffic flows. If one of the layers constructed wrong, maybe someone finds a loophole into that and that's blocked. Whom do you blame? Same thing is with Docker. It's a piece of software, come on. Okay, it's bound to failures, but till now, no one has reported any such kind of things that the Docker stalls or something. It was a case with a few of the operating systems, but I guess these people have been working on it and fixed that. I have also seen such problems going on with VMware as well as VirtualBox, so that's not a big deal. But you're right, that would be the case. Another question from Fanindra. I have virtual machine, vSphere. How can I build a container of it so that I can use it in another machine? Well, great question. Let me pick up the basics first. I'll show you how to install and have your own operating system inside of Docker, and then we can go and set up the things there. Okay, makes sense? Another question coming in from Rajit Kumar. What is the difference between Docker and Chef Puppet? Okay. Um, Very first, Docker is a virtualization technology which is based on containers. That's completely different. Chef and Puppet are configuration management systems which help you configure the stuff. So your Puppet can help you configure a Docker image for you. Your Puppet can help you configure different machines, Nagios, web servers, or set up your nodes, but that cannot be done by Docker. Docker in itself is a virtualization technology that you could build from a single file. Just like if you are aware of what Vagrant does, Vagrant can execute a script and it can build your virtual machine. So Docker also has a concept of Docker file on into which you could write some configurations, and based on that, Docker would create your Docker images and your containers. Okay, but Puppet can create a Docker image. It wouldn't be uh, compared to that. Those are completely different areas. Okay. There's another question coming in from Rashmi. Can we create template from Docker container so we can reuse that in another ecosystem? Yes. And Docker is great at portability. They are very light. In the first case, you could commit the stuff, you could review it again, you could export it to some tarball, you could bring it to another machine and again import it. Okay, so that's possible. There is a Docker registry which holds the images for you. So you could have two different kinds of Docker registries. It could be third party or hosted one, which is provided by Docker themselves. Another one, you could have it in your own environment locally. Okay, so in your own production systems. So you could tell Docker systems to connect to that repository and pull down the images and execute it. So Docker is really great at portability. And that can also be reused, right? So if you have it portable, you could reuse on other systems. You could import it or load it. Both of them are commands. You could type in as docker import, docker load. I'll show you how to do that. Another question from Vikas: how Docker would be better than Vagrant? We use Vagrant extensively. Um, see, comparing Docker to Vagrant is same as comparing their end products. Now these two are technologies. End products would be Docker containers, and Vagrant's endpoint would be your virtual machines. So I've already compared both of them, right? It's up to you which one to use in particular ecosystem. If you're talking of deployments, I would really go with Docker. It's really great tool for deployments. The reason why, since we can package everything along with the dependencies, we create a complete environment. So instead of sending the code out, just a bare code, I would run that code in my Docker container, check whether it works or not. Okay, commit that Docker container to my repository, tell the production guy to pull the Docker container from the current repository so that I don't have to worry about which configurations to set, what to do with that, how to install the stuff, how to manage dependencies. I just tell my production guys that pull that image from there, which I have committed, run on your systems, and that's it. No more hassles, nothing. So the environment would be replicated as it is onto the production environment. And not just on one single machine, you could have Docker running on all of your nodes where your code has to be deployed. And code would be deployed along with the web servers with all the configurations right, and the systems would be all up. No time. Okay. It takes some time for your virtual machines to boot, but for Docker, it might take a second or two, not even more than that. So there is another question coming in from Sandy. We can also share the VM right from the test production environment. Um, we will take the snapshot of test environment and send the snapshot of production environment so that they will use this image to launch new VM. So VM is also portable. Okay, let's buy it for a minute that VM is portable. You know that VMs are closely affiliated to their underlying hypervisors. So if you are aware of VMware and their various versions that they support, right from VMware Workstation 5 to Workstation 11, you have options of choosing VMware version just because they are required for a specific feature, plus they have different capabilities related to hardware emulation. Okay, so if your hardware emulation is not done right, your VM wouldn't work there. Okay, so that's the problem. So if you say that VMs are perfectly portable, no, that's a problem. And another one is VMs are too bulky to be considered uh, to be considered as an artifact for deployments. You don't want a 5 GB artifact to be transferred through your network onto your end node just because it is built in CentOS and has got some packages installed inside of it. Doesn't make sense, right? Instead of that, you would easily or happily port something which is 20 MB in size or has a few MBs more than your code repository size. That's a good idea, right? That's what we believe in. And if you create a tarball out of it, you could simply rsync your tarball out. So it would copy only those parts which are changed. So you don't even have to copy the complete Docker image to your nodes. And that's the best part of it. We save bandwidth, we save time, we save the restart time of your nodes, and great portability. There's another question here from Anita. So which one is more popular these days, Docker or hypervisors? See, honestly, the cloud business currently is working on VMwares, not VMware, virtual machines. So VMware is one of the providers. So today, if you're talking of cloud, it is all virtual machines. They do have support for Dockers, but today it's extensively all about virtual machines. Docker is a future technology that has got many promising goals to achieve in near future, and we see that the DevOps in the near future would be all going towards Docker containerization business, not the virtual machine business. Okay, so currently your VMs are famous, but they are quickly losing their stakes, and people are jumping to Docker more. Another question here, what is the use case to use Docker onto AWS cloud? Is it cost effective? Okay, one of the use cases I've told is deployments. Okay, another one would be to have your machines converted into non-service affiliated systems. So if you ask about the Google architecture, their one single machine would be running Gmail processes as well as their Google services as well as their app engines as well as their search engines, and they don't care which one runs where, as long as the resources are all optimized and they are used to the perfect level. Okay, but these days if you talk of your cloud infrastructure, we bind the services to a node. I say that this particular cluster, it should be serving only the web request. That particular cluster would be serving only the database request and so on. What if I unify them together in a swarm or a pool of systems, and I want Kubernetes to handle it for me? So Kubernetes is a system that would be controlling all the resources in my data center, and I just tell Kubernetes that these are the processes that I want to run. Now, pick up these Docker instances, run them anywhere, I don't care. Just I need to be sure that my systems are performing at 75% or 80% resource utilization, and the utilization should be optimized. So that's what is the end goal. Okay, and that everything is handled by Kubernetes in that case. So we don't stick to the servers. We don't stick our services or bind our services to the machines. That's one of the biggest benefits of Docker, which will never be given to you by any of the virtual machines. Another question from Anita, can data centers use Docker instead of hypervisors? Why doesn't Amazon Azure use it instead of hypervisor? That's what I said. These are the money businesses. What's famous is being used since ages. If a technology is new, people generally adapt it with time. Okay, so it wouldn't be right to say that they don't support it. Amazon supports Docker as well. It's all up to you whether to use it or not. Extensively, if you go with all the default settings, they will provide you with a virtual machine, not a Docker container. And Dockers and hypervisors are completely different. If you have a setup which is running hypervisors extensively, you would be running only a virtual machine on top of it. You cannot run Docker. For running Docker, you need a very minimum operating system at the base, which will be providing you with a kernel. On top of that, you install a Docker engine, and then you go on running the processes on top of it. Okay, so there's a little comparison between them. Another question from Fanindra. To create image, we need to have a tar file. What about size? That's minimum. Let me show it to you. So we are already 38 minutes down. I would quickly jump to what we have to offer from hands-on perspective. So what I need here is a 64-bit machine. Docker doesn't install on 32 bits. That's bad. Okay. So Docker guys are not providing any support for 32-bit systems. So what I have here, let me bring up my systems. I have my VirtualBox manager. I'm running a Windows machine just because it came pre-installed. No big reason for that. That's why I'm using a hypervisor to emulate a kernel. On top of the kernel, we would be having a Docker installed, and then I'll show you some basics with Docker. Okay, so that you know what are the different things that you should be doing differently when it comes to virtual machines in Docker. Okay, before that, there is another question coming in from Vijay. Could we set up different containers to have different priorities with respect to criticality? That is what I mean is some containers may be running apps with higher business value than others. Yes, we could do that. If you check your PSOX for the processes which are being running, you see the Docker containers running there. Okay, so you could change the priority. Now these priorities can also be handled by some resource manager like Kubernetes for you. Or there is another nice product from Docker. It's called Docker Swarm. That can also help you do the same thing. Okay, so it's not that we are running into the problems for the very first time. People have been there already, and there are solutions. Another question here from Manish. So if I use Docker, do I need Chef Puppet for configuration? Oh yes, you do. The reason why, Docker would be running your applications at isolation level. Okay, so for running Docker, you need Docker package to be installed on an operating system. You need an operating system installed on a virtual machine, or it could be virtual machine, it could be a physical box. If it is either of them, you need a Puppet or a Chef or any of the configuration management system to either configure it for, to configure that particular machine for you. So you would be installing Docker on it, you would be setting up some configuration scripts, you would be running the Docker containers on top of it, right? All these processes has to be automated. So there's no option for Puppet and Chef in that kind of scenario. You could also use Ansible if you want to. So what I have here is a machine, so which I would be cloning. I have a template here which is 64-bit template. So I would say it's Docker 1 for me. I've kept Docker installed just to save a few minutes of time, but I'll still go with the installation. I'll show you how to install it. So the kernel version that you need to have is 3.1 plus. So if you're running kernel version 2.7, Docker wouldn't work. Another bad news. I told you that was a future technology. So these days, everyone of us is jumping to 64 bits. No one uses 32 bits. So these people are still new at stages and they are building the stuff. Okay, so don't depend on them for faster round trips or faster turnaround times for the bug fixes, all this kind of stuff. But they are working mainly on getting the feature-rich product out in the market. Another question from Sandy: are you installing Docker on a VM? Yes, I am. Reason? Because I don't have a kernel in Windows. Windows doesn't support containerization or Linux containers, to be very specific. So what I'm going to do is I'm first trying to emulate a virtual machine, trying to emulate a Linux system, which will be providing me with a kernel. And on top of that kernel, I would be installing Docker. So just we would be uh, pretending or just pretending that I don't have Windows machine, I have a Linux machine on which I would be installing Docker. Docker is not actually dependent on VM. I am dependent on VM because I am using Windows. Okay, that's the only reason I'm doing it. If you want to run Docker inside Windows, there is a package in Windows which is called boot to Docker. What actually it does is it would be creating a virtual machine with a kernel inside of that, and then it would be installing Docker packages. Okay, so if I didn't have Windows box, I would be installing Docker directly. So it is a 64-bit machine that I'm bringing up. Another great question from Santosh: can we have Docker behind load balancers? Let me ask you a reverse question. What lies behind a load balancer? Is it a machine? Is it a service that we are targeting? We are targeting services, right? So if we are targeting services which are isolated all across the boxes, and all that box I could run Docker, then I could place Docker behind a virtual machine, behind a load balancer, right? So it could be a box running a Docker instance who has got a port exposed, okay, and that could be placed behind a load balancer. Would work. So when we are talking of um, deployments at scale, we need load balancers. We also need Docker containers for faster performance. So combination is good, it works. Well, first I'll just make some changes. Let's call it Docker for now. And okay, so that's my box. I can ping to internet, should work. Okay, so internet connection is there. Another one, I want to connect to it from my local connection, SSH connection rather. The reason, because I want it to be more bigger in font size. If it's okay for you, then I wouldn't be doing any configuration on that end. So is it visible? Is the black and white screen visible, and can you read from it? Okay, thank you. So let's install Docker. So for installing Docker, you need to follow the instructions which are provided by the Docker people on this website, which says docs.docker.com installation on Ubuntu Linux. So I would be following these steps. Now these steps are number 10. From 1 to 10, you could follow every one of them and install your Docker instance. Okay. Eventually, what you get is a Docker engine. That's the package, Docker engine. Once you install it, your Docker would be running on your system or bare. Okay. So let me follow a few steps. Rather make some changes here. Let's see. network interfaces. Let me add another one. The reason I'm doing that, I need to copy paste a few things, and for that I would be needing a client. If I pick h1, okay, so there it is. So let's bring up a putty session on IP address 192.168.56.102. Now this is not very specific to you. It could be just specific to me. Okay. So all you need is a system on which you could connect as a root. So let's see what we need to do here. So I'll pull up this page for now. You can go through it at your own pace. So I'm following the steps. First things first, login. Okay, get root. All right. So what essentially we are doing is we are updating the source code, then we would be adding a source list. After that, we would be updating it again. And then we would be installing the package called Docker Engine. But let's do one thing. Instead of following all the steps out here, which anyone can, okay, so I'm simply following all the steps to install Docker. We wouldn't be wasting time on setting up the things here. It's very, even if they are just 10 steps, they are practically just two. Add a source list, install the repository. Why do we need a source list? Because there is already a package called Docker which is available online, but that Docker and this Docker that we're talking of has no resemblance or no matching between one another. We need to add a separate source list here in this file and then install Docker Engine. So what I'm going to do is I will show you the pre-installed version of Docker. See, what I said is true. You could simply do Docker install, apt-get install Docker Engine, and there would be your package. That would, if I skip this, it would save us a few minutes. So we are already running out of time. So let me get that Docker machine up. I would say let's shut it down for now. And I'm connecting to another box. So if you have Docker installed, if you type in Docker, you would be getting a list of all the supported Docker commands which are there available with the Docker engine. Okay. So I was talking of the repositories, right? So if you want operating system to be installed inside of Docker, very closest operating system or the very smallest one that you could install is BusyBox. If you don't know what BusyBox is, it is the minimum version of Linux. It's a bare minimum version of Linux, which is hardly a few MBs in size, which you can download and then you could fire commands on top of it. Okay. So what I did was I simply did docker pull BusyBox. Where does it connect? It connects to the centralized Docker repository or registry. And to view that registry, let me break it up. Here, you could say Docker registry, and the URL is hub.docker.com. It's also called Docker Hub. So here at Docker Hub, people have contributed from the open source community. They have contributed to the different images that you could readily use. You don't have to go and configure all your images all by yourself. So what we do is we pull it from this. So if I type in BusyBox and I want to check whether BusyBox is available here or not, we can search for that. It would get back to us with the result. So this is the list. Here it would come back with the result. We will wait for it. So if you see the official repositories, we have repositories for CentOS, we have BusyBox, we have Ubuntu, we have some more operating systems already there. But these operating systems just hold the file. They don't have their own kernel. The kernel is provided by the underlying host operating system. Okay, even if we see the operating systems here, these are not the full-fledged operating systems. You cannot run them on their own. It has to be executed inside a Docker container itself. So if I talk of Ubuntu, what do you think how much would be the size of it? If we download Ubuntu 14.04, so if you want to pull it from here, if you want to use the image which is currently created on the centralized Docker repository or Docker Hub, we could type in the command which says docker pull. Okay, and this is the command in here. It is mentioned here, docker pull command. Docker pull image name is Ubuntu. If I want to pull an image for BusyBox, I would be doing docker pull BusyBox. There are multiple versions of it. So if I type in docker pull BusyBox, it would be pulling all the supported images, but we don't want all of them. So if you check here, there are 4 different versions of Ubuntu which are mentioned here. Okay, out of all the 4 versions, I want just one. So I need to specify which one. By default, latest is the one which would be sent. If you don't specify anything, everyone would be pulled in. So if I want the latest, I could say colon latest, where BusyBox is the image name, colon, and something after it is a tag. Just like the revision, here we say that it's a tag. So let's go back and download our BusyBox, or maybe even, okay, I'll download the BusyBox. It's very small in size. So I would say BusyBox latest, pull it. It would now connect to the Docker Hub, pull the image from there. It is also possible to create your own local repository so that the Docker container, the Docker engine would be connecting to your own repository instead of the remote repository. So it says it's pulling from the docker.io library / busybox. It would take some time to connect, figure out the different layers, then download those layers and prepare an image. Okay, network timeout. Please ping google.com. Can you connect? So by the time we figure out these things, do we have any more queries to be answered? Okay, so this is bad. Let me recheck what's the problem here. So there is a question here from Santosh. So do we bind Docker IP or the host IP in that case? Okay, the case was about using load balancers with Docker. We don't bind the Docker IPs. Docker IPs are very much internal to the host machine. Okay, you could only use the IPs if you want to connect to that Docker IP from the host box. In case you want to expose that Docker process outside, you would be exposing that over a port. Okay, so you could expose ports in Docker. So you'll be binding it to the host IP and Docker port. Another query is coming in from Mr. Manish. Can you install Docker on Mac directly or do you need a virtual box? Mac does support containers, so we can install Docker directly on Mac. Okay, so finally I have that running. Let's hold it for a minute. I'm connecting to my Docker instance. Another question from Rashmi: for application testing, it's worth, but how it's applicable for storage testing like SAN or NAS? Okay, there is persistent storage option in Docker. So if you want to make the storage persistent, in that case, you write to actual host machine. So Docker containers are very much volatile. Okay, once you stop the execution, Docker containers are stopped. All the data which is supposed to be dynamic or which is kept in your RAM or internal disk would be lost if you kill that particular container. Okay, after stop, it can be destroyed later on. So if you don't want the data to be destroyed, even in case of testing, you write it not to the Docker disk, but you mount some disk from the host into Docker and write to that particular part of it. That means when you write to it, your data wouldn't be written to a Docker container, but it would be written to the host or any other mounted network. It might be SAN, it might be NAS, whatever you want to do. Docker pull, we were trying about BusyBox and the latest tag. Okay. There is another question from Fanindra. I want to create image of one VM. How can I do that? Well, I'm not sure how it connects to Docker. I'm not sure whether I understand the question. If it could be more elaborative, I could take it again. Another question from Sandy: which language you use for Docker file? Docker has got its own language. It's pretty much declarative. If you look at that, there would be very few keywords. It would say pull, from, add, copy, and something like that. Very few keywords are there. Okay, so that's very simple. If you check here, we have typed in docker pull busybox latest tag. It has started pulling the repository from docker.io/library/busybox. It is pulling the metadata. Now it's pulling the FS layer, and the downloads have been completed. There's something it's waiting for some more layers to come down, and now it's there. Okay, so we have downloaded the busybox. If I want to check which images I have, I would be typing in docker images. So currently I have busybox image. I have already kept Ubuntu image downloaded. But if you check the size, your BusyBox image is nothing more than 1.33 or 1.113 MB, and your Ubuntu is nothing more than 188 MB. Okay, so Ubuntu doesn't come in packaged at that size. If you talk of kernel and all those supporting um, stuff, which is common in most of the operating systems, that part is completely scrubbed off. So that part would be picked up from the virtual machines kernel on which I'm running the Docker. Okay, so if you type in Docker info, it would give you the information about the current Docker installation, your system's configuration, what is being used currently. Okay, so that's one. We have pulled the image. Now we are ready to execute the container. Container would execute only till the time in which the process executes. So if the process terminates, your container will automatically terminate. It wouldn't keep on executing. So the containers are tightly hooked with the process executions. If your process is not running, the container will not be running. If your process runs, the container runs. It also means the containers will keep on running till the point your process is still running inside the container. So let's do one thing. Let's run a process. So I have a Docker. I want to run the image BusyBox. If I don't specify anything, that is supposed to be latest by default. So that's BusyBox. Let's execute echo. Okay, and echo what? I could say hello Docker for now. So Docker run is the command which helps us in running the Docker containers. Basically, we run the images into a container. So multiple containers can be executed from one image at a given point. Okay. So if I hit enter, it would say hello Docker, which is supposed to be the result coming in from the container. But does the container run? Okay. Is it still running? How do we know that? We could check by typing in Docker PS. So it gives you a list of currently running containers. The container is not running currently. So how do we check? I check PSA, which would give me a list of all the Docker containers running. All the Docker containers which have been not deleted and are still there on the disk, but they are not running. So the latest one was BusyBox. Okay, containers are identified by container IDs. The commands that were supposed to be running inside that particular Docker container, its status. Okay, so currently it exited with a success which is 0. In case of Linux, 0 means success. Anything which is non-zero is error code. And if you have exposed any of the ports, it would show it here. So let's say there's a question here from Mr. Santosh. If he has an application running on Docker on a particular port, for example, Tomcat on port number 9080, how do I bind this application port to Docker assign port? Awesome. So let's do one thing. We were supposed to be running an application. So instead of doing simply echo, bin echo, I would be running a Docker, I would be running a server by typing in some command for the start script. I don't know what is the path, but probably this would be the case. So start would be your script name that you're supposed to be running for executing a Tomcat inside of a Docker container. Okay. Here I would be providing the port. I want to map the port number. Let's take it port number 8080 on my host machine should be mapped to port number 8080 inside the Docker container. That's how I map it. If I want to map multiple ports at the same time, I could say port number 80 should be mapped to port number 80 inside Docker container. The first part is the host part, the second part is the container part. Okay, I hope that answers the question. Okay, so what if there is a continuously running job? Then the Docker container wouldn't terminate. Okay, how do I show it to you? So let's say we have a sample job. Currently, I'm just typing in a very sample job here. Singular Docker run -d is daemon. We are running BusyBox. and I would say execute bin sh with a code which says an infinite code. While true, you could run something as an interactive shell, which is also a non-terminating process. Okay, I'll show you the interactive shell shortly. Echo, maybe I say Docker, and let's keep it sleeping for 1 second. Done. So that's a small shell script to create a infinite loop that would be sleeping for 1 second in between and echoing Docker out. So what I did was I executed a Docker container, and I have assigned the reference to a variable called sample job. Okay, so if I've done that, how do we check the logs? What's happening inside of sample job? So I would say Docker logs check sample job. Okay, so there is some output which is coming in from that Docker container, and we are looking at that particular output. It is checked by typing in Docker logs. The container is currently executing. If I check the Docker command, Docker, sorry, Docker ps -a. We don't have to type in -a now because we know that the container is still running, and we are checking the logs by typing the command Docker logs, which is we are executing outside the container. For maybe any reason I want to attach back to that container, how do I do that? I would say Docker attach. Docker attach to what? Docker attach to a container ID. And now I am linked to the console of that particular container. So if you see the output, it is just like I am directly inside that container right now. So if I kill it, I'm out. The process terminated, the container terminated. If you type in Docker ps again, you wouldn't find anything. Docker ps -a would give you a list that this was the command which was executed, and it terminated about 8 seconds ago. Okay, another example. Let's say we have a Docker container which I want to run, and I want to have an interactive terminal -t-i, and I want to have it using the image called Ubuntu. Okay, and what is the environment I want to log in? It is bin bash. So currently the container is created with ID 83E67 something. Okay, and I have a terminal now. I am a root. Whenever you log in into a container, you get root privileges. So you are a root, and you could now install any package inside of it. If I want this Docker container to be treated as Apache or a web server, I would say please install Apache to inside of that Ubuntu container, and that would work. But remember, I'm now installing it inside the Docker container. I'm not installing it on the host, so I'm not polluting the host. The Docker containers would be reusable. If something doesn't go right, I could say scrub it off. Okay, and my host machine still remains pure. So let me show it to you how we are doing this. There is another query coming in from Fanindra. I want to build a virtual machine image and make use of it using Docker pull in another VM. I want to build a virtual machine image and make use of it using Docker pull. I'm still not sure what you are trying to do. I'm really sorry for that. I'm not getting your question right. You're trying to build a virtual machine image. Okay, I got it. It could be a VDI image if possible, and make use of it using Docker pull in another VM. How would you push another virtual machine's image in another VM? Sorry, Fanindra, I'm still not getting it. If you have got time, we can talk maybe at the end of the session and spend some more time on understanding it. Or maybe you could, I could unmute you and we could have a chat. So we have downloaded Apache. It would be installing it. So what I've done is I'm running a Docker container right now. I could stop this Docker container. I could start it again, and we could find the same number of files which are written to it right now. So how do we get out of the Docker container? Simply type in exit, and the Docker container would be terminated. So let's try it again. Docker ps -a. It exited 5 seconds ago, which was started with Ubuntu. How do I start it again? I would say Docker start. Start what? Start the container. So the container started. But if the container started, was it interactive? No, it wasn't. Okay, so it's not an interactive terminal now. It's running in the background. So there is a server inside of it which is installed. It's running. Okay, it's running in the background. How do I attach to it? I could say Docker attach to. Now every time if I have to remember the ID, that's cumbersome. Okay, that could be a problem. So we don't want to remember the IDs. What we could do is we could, instead of that, we could name the different uh, containers that we are forming. Okay, let me check if Apache is here. If you cd to etc Apache, so there's a folder. Apache has been installed. Okay, I can terminate it again by typing in exit. I'm off. Okay, nothing is running. You could start it again. You could attach to it, and if you want to execute a command inside of a Docker container without getting inside of it, there is a command called docker exec or execute. Okay, you could use that command to execute the commands inside of a particular Docker container. So you'll have to remember the Docker container ID again. So for now, I'm getting rid of the Docker container IDs, and I would say I just want Docker to run a container in interactive mode. Another one using the image called Ubuntu, but this time I want it to be given a name. I would say that the name should be demo. Okay, and the command I want to execute, bin bash. So currently I'm in the interactive shell. I'm getting out of it. It terminated off. You check Docker ps. It isn't there. Docker ps -a. If you look closely, the name part here says demo. So if I want to attach to that container again, I would say Docker start demo. I don't have to remember the container ID. Then I could say Docker attach to demo, or we could say execute some commands on demo. So we would execute something like bin echo hello world, and that executed back. Okay, it's completely running in isolation. I would say Docker stop the container demo now. Okay, stop demo. It stopped. I could commit it back. So before committing, I could check the difference on demo. So what changed in demo since its last execution? History file changed. Okay, there's another one which checks Docker history on the image. If you want to check the history of image, you could type in Docker history. If you want to check the differences between the container from the point it started till the current point, you could type in Docker diff on that particular uh, container. So you could get a complete diff set. You could also check the difference between the two images if you want to. If you want to push the image back to the repository, you could type in Docker push and the image name. But before pushing the image, you need to commit that image, right? So I have a Docker instance. We have named it as demo, and okay, there was one more, right? Let me check. I'll show you the diff of it. Docker ps -a, and we have executed Apache installation in this. So I would say Docker, give me a diff on grave brown. So if you check closely, a whole lot of files were changed or added. Okay, so Docker maintains the list of everything that was changed in a particular container. You could figure out what's there. It's just like a small revision control system, but for the operating system as a whole. All right, so how do I commit? I would say Docker commit back, commit what? Commit the image named demo, sorry, the container named demo to the image. You could give any name to it. Currently I'm saving it with the same name Ubuntu, but I want a different tag, so I say Ubuntu demo. It had committed it. Let's get back and check Docker images. You would be having the fourth one, Ubuntu demo. Ubuntu latest was already there. We have committed one more with the same name Ubuntu and a tag called demo. If I want to push it back, so I would say Docker push Ubuntu demo, but I don't want to push it to the public repository. It's not fair for other people, so I'll leave it for here. I wouldn't be pushing the contents back. There are many more things that you could do. You have seen how to expose the ports. There are stuff like linking the two images together, creating the difference of it, which we have seen how to attach to the Docker image, how to execute a command on the containers directly. Okay. Also, I've seen how to stop it. The last basic stuff that we want to do is delete the mess that we have created. Okay, there are ways to import and export. So I could simply do some exports from image. So Docker export Ubuntu to some repo.tar. Sorry, it's not Ubuntu, it's container ID. So my demo container would be exported to a file called repo.rar. I could mail it to you. You could download it, use it again somewhere else. So this offline portability. Online portability is just pushing to the repository and pulling it from the repository. Okay. There is another way of doing it. You could say not export. You would say something like load. Um, There's also a command called save. So save would also work in this case. So let me check how save would work. So save works on an image. Currently we worked on a container, Docker save image, and image name is Ubuntu, and we could send it across as image.tar. It would be dumping that image to the image.tar file. If you want to load it from the image, instead of save, you use load. If you want to import it from the repo.tar, which is the uh, container archive, you could use it using Docker import instead of export. Okay. If you check the disk, there would be two tar files here, which is useful for offline transport of files. So instead of pulling it from the centralized repository every time, what we could do is we could create the tar files and then use the mechanisms like rsync to deploy it to all our nodes at once. Okay. If you check the sizes of it, 197 MB along with Apache package installed. So it doesn't take much of the space. So that's all about Docker basics that I had to deliver today. Thank you so much for patiently waiting for all the stuff to go by and bearing with me during the time. Any more questions that you think I would be answering? Anything you have, if you want me to get into discussions with you, please raise your hand. I can unmute you and we could have a small chat. Yes, Mr. Santosh. You're welcome, Rashmi. Any more questions from anyone else? Sorry, Santosh, if there's a problem with the mic, you could type in your query here. Can we have the question from Santosh is, can we have our own local repository? Yes, we can have it, and it is also called local repository. So what you can do is you could have your Docker systems connect to your local repository by using the login command. Okay, the command's name is login, and you could log into your local repository first, and from there you could use it. The syntax is like this: Docker login, Docker login to your local repository. So maybe you could say localhost, something called port number 8080, which is by default there. If you have it on some another machine, you could say my Docker is running on some another box. Let's see, it is, or in DNS we have set it up as docker.example.com on port number 8080. So you could use all the images which are pulled on that particular machine. So let's say on my particular box right now we have two images which I have pulled, and so if one of my friend is using my system as the repository, as a centralized repository, he could use both of those images that I have downloaded. Nothing more would be available for him, but he could use just mine. So in that way, he prevents himself from connecting to the internet. Okay, that's not required in that case. There's a question here from Fanindra. So Fanindra, I'm unmuting you. All right.
Hi.
Hi.
Can you hear? I have a virtual machine.
Okay.
In that, JBoss is running on it,
Okay.
and I have installed some RPMs in it. So
Okay.
I want to create an image of it and then make use of that in another virtual machine.
All right. So we don't have to do that in the first place. Okay. How do we
So
deal with
I
this
don't want
problem?
to. Don't want to. I mean, take anything like image predefined Ubuntu image or anything. I have already a setup, and I want to create an image of it and make use of it in another machines.
See, Docker images are completely different than your virtual machine images. Docker images are a very specific layered file system which is not understood by any of the virtual machines, and neither can Docker understand any of the VDI or VMDK extensions. So that is completely different. Okay, so what you need to do is you need to have the bare operating system from Docker and reset up all those things that if you want to install JBoss inside of it, you will have to do it on your own first, save that image, then reuse it. If you don't want to do that, there's better option. Go to Docker Hub, check for JBoss. There would be some JBoss repositories already there. Okay, so you could use it from JBoss Wildfly public repository. You don't have to install anything, simply download by typing in docker pull JBoss. It would be helpful, and after that you do your own configuration. That would be one time setup that you would be doing, and that's all is required. You cannot have virtual machines images running in Docker. I hope that answers your question,
Okay.
if I'm right.
Okay. One more thing, we are creating a tar file out of it, right? The tar file will be the size will be very large, right?
No, it's not very large. If you have seen, we had Ubuntu operating system plus we had Apache installed on top of it. Total size was 197 MB.
And the second question is, we have a Vagrant and Packer, right?
Yes.
Packer also, right? So we need to have a JSON script kind of thing to create image out of it. So I'm facing a problem with that creating a JSON. So
Mhm.
can you help me in that?
Um, See, Docker and Packer are more similar. Vagrant is a bit different. So Vagrant would be related to virtual machine stuff. But if you're talking of Packer, it's a technology which is created by Microsoft guys to have containers supported on their own system. So this is not a Linux container. This is a new Windows technology that supports their own containerization, and it's called Packer. That's what they use. Technology wise, the scripts that these systems support are completely different and vague, so I wouldn't be able to help you out right now with this. But if you have any more questions, I would be happy to help you.
Okay, thank you. Nothing
Yeah,
else.
you're welcome. So guys, that's all I have to offer. And if you have any more queries, please feel free to shoot up. I'm still here for another 10 to 15 minutes. If you sign off, there would be a survey which would be popping up in your browser. Feel free to provide your feedback on it. If you need the recordings of this session, the recordings will be provided to you within 24 hours of the session completion. Any more queries? Anyone? All right, guys. Okay, there is another query coming in from Fanindra. Can we make use of OVF template? No, we cannot. OVF template are very specific to importing the appliances on virtual machines, for virtual machines. That's completely different. Okay, virtual machines are different than the Docker containers. We cannot do that with Docker. All right, guys. In that case, we will be signing off for today. Thank you for sticking around with me for another very good of 30 minutes. I appreciate that. I'll see you around. In case you have any queries or feedback to offer, fill up the survey form. You could also get in touch with Edureka guys for any of the questions regarding this particular seminar. Thank you so much for attending the seminar today. Have a great week ahead. Thank you.